So as of yet, I've not explained what subnetting actually is. Like, I didn't understand subnetting before I actually really understood what IPv4 addresses were, and that they're made up of like 32 bits, four quartets of 8 bits, and that like how that's represented in binary, and what subnet masks, what the fuck they were. So I'm kind of just assuming that you didn't get that yet. Sorry if you did, um, but hopefully this is making sense. I'll just kind of carry on. But I'll get to subnetting after all of the basics make sense. Okay, so I explained how these 192.168.0.7 or 16 or whatever addresses are typically found in the home. The subnet mask for these addresses is typically 255.255.255.0. I explained like they're found in the home because only this last quartet is dedicated to hosts like your TV, your smart TV, your smartphone, your PC, your fridge, your whatever is on the internet at your home, because they all need to be on the same network and they all need a unique address, right? The subnet mask is representing, it's just showing you that because the 255 stop here, that these are all your hosts. This is your space for your hosts. Your hosts can't go on this section, they can only go on this section because the subnet mask is telling you this is your network, this is the space for the hosts. And the reason we find these in the home typically is because people don't have usually more than 255 different devices in their home that they need a unique address for, right? So having just this last quartet dedicated for devices is totally fine. How many more circles can I draw around this? Having this last quartet dedicated just for your hosts is usually totally fine for the home, so there's no need to complicate it. But if you were working in like a big company, you need thousands and thousands of computers all on the same network so they can communicate. Having just this last quartet, which gives you 255 different unique addresses, isn't going to cut it because you need thousands and thousands of different unique addresses all on the same network. So you need to basically dedicate more of your IPv4 address to hosts rather than your network. Okay? So that's where different classes of IPv4 addresses come in. So the classes of addresses are one sec. So the classes of like private addresses, reserved IP addresses, don't worry too much about the terminology, but the different classes are 10 dot blank 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 blank, such as the one I just showed you there. So you see this address here, 10.2.42.16. Note how it's different to the 192.168.0.7 or 16 that we started with. It's 10.2, right? It's way lower. And that basically shows you these 192.168.0 addresses, they're Class C addresses. You see this? Class C. Class B addresses start with 172.16 to 31. Don't worry about that. Just remember, if it starts with 192 dot blank blank blank, it's a Class C. If it starts with 172, it's a Class B. And if it's all the way down at 10, it's a Class A. And what that means is there's more space dedicated to the network and more space dedicated to the hosts on different classes of networks, right? So for these Class C addresses, the 192.168s that you find in the home typically, as we said, not much space for the hosts because it's just not needed. A lot of space for the network. But these addresses, they will have, because they're Class A addresses, there's much more space for hosts, much more space for hosts than there is for the network space. And that's represented in the typical subnet mask for this kind of address, for a Class A address, which would be 255 255.0.0.0. Instead of 255.255.255.0 that we found with the class C addresses, instead it's 255 just one time, just one quartet, and then the last three quartets are zeros. And if what I said before actually made sense, if I actually explained it correctly to you, then you would have like picked up that all of this now is dedicated to hosts, rather than this one where only this last quartet was dedicated to hosts because of the 0 in the subnet mask. All of this space now is dedicated to hosts, which means you can have for a class A address, you could have 10.1.1.1, and then you could have 10.1.2.1, and then 10.2.2.1. That you could have them like 10.1.0.0, and then 10.2.0.0, and 10.3. All for devices all the way up to 255.255.255, which is obviously an insane amount of devices, right, that you can have on this one network. So that's the point of different classes of networks. Obviously, there's no point having this kind of address at home because you just don't need that much space for devices on a home network. But in a big company, you need that much space, probably. So that's the point of that. And something I should explain, it's just a side note right now in case this is confusing. You might be thinking like, why does this class C address have a subnet mask of 255.255.255.0, but this class A address just has 255.0.0? Why can't it also have 255.255.255.0? And that's just because of the class system. If it's class A, this is what you're going to go with. If it's class C, this is what you're going to go with. If it's class B, can you guess what you're going to go with? So a class B address would be 172.16.42.3. And the subnet mask for that is class B. So class C has these three quartets dedicated in the subnet mask for network, and the class A has just the first. I did this in a weird order right now. And the class A address has just this first quartet dedicated to network. Then the class B address, what do you think? It's got the first two are dedicated and the last two are zeros. So looking at the subnet mask, it's on here, all ones, so that's showing us that's the network portion, and the zeros start here. So the part, whoops, I just like scribbled right through that. So the part of this address where the hosts can start being assigned is this, the last two quartets. This is a network, this is your host, right? So for this one, you could have like your PC could be, or like a PC could be 172.168.4.3, and then 172.16.5.3, and then 117.16.6. Each for different devices, right? Because these ones can all be given like unique numbers for devices.